Hello and welcome to this Rhapsody Tip of the Day video. My name is Frank, I'm a passionate Rhapsody user, trainer and consultant and love to share knowledge to help you to become more effective. Today I want to show you how to co-simulate state machines and activity diagrams in a single context. A state machine can be used to describe the state-based behavior of a block throughout its life cycle, which is defined in terms of its states and transitions between them. On the other hand, activity diagrams can be used to express in more detail what happens when a block is in a certain state, or when it transitions between states, or when it enters or exits a state. This leads us to a model that consists of both an event-based state machine with flow-based activities. Let's see this in a model in more detail. In this model I have a block counter which consists of a block property count, which we're going to increment with an operation doCount. Beside the increment operation doCount, we have a reset count to reset and initialize the count to 0, and an operation printValue that allows us to print any generic integer value on a terminal window. The block also has an event reception and is able to receive two signal events to define the event-based behavior that will trigger a state transition to start, respectively stop counting. So let's take a look into the state behavior of the block. This little icon, called Quick Navigation, indicates that the block has a state-based behavior. Simply click on the icon to navigate into its state machine. In this diagram you can see that we have two states, off and counting. We also see that the initial state is the off state. When entering the off state, we call the operation resetCount as given in the block's behavioral property as the entry behavior. This operation will initialize count to 0 and print the value to the terminal window. The event start counting triggers the transition to go from the off state to the counting state. To make life easy, I have added two buttons to inject these events into the model. When we are entering the state counting, the operation doCount is called as the state entry behavior. The special thing about this operation, its behavior is specified by an activity diagram. So let's navigate into the browser to open its diagram. I have added the following three actions to specify doCount. The activity starts with the initial node called initialFlow in Rhapsody and then proceeds with getCount. In the getCount action we read the count property from the block instance via the accessor getCount and assign it to currentCount. When this action is finished, currentCount is transferred, flows via pins to the increment and setCount action. The control flow here is optional, because the flow direction is unambitious in this simple case. The increment and setCount action takes control as soon as there is value on its input pin. In increment and setCount we increment currentCount and assign the result to newCount. We use the mutator operation setCount to write newCount to the block's value property count. The newCount value continues to flow into the printValue operation. The printValue operation is a behavioral property of the block counter, which is called in this action. That's why it's called call operation in SysML and indicated by this little icon. And again, this icon is a quick navigation in Rhapsody. When you click on it, we jump to the browser to open its implementation. You can simply drag and drop the operation from the browser to the diagram to use it, whenever and wherever you want. When done, we terminate the doCount activity with the final node. Now we jump back to the counting. The counting state has a self-transition which is triggered via a time event every 2000 milliseconds. On re-entering the state, the doCount activity is called again, and it's repeated every 2 seconds. We remain in the counting state until the transition to the off state is triggered with the event stop counting or on any failure event. Let's start with execution. Before we start the simulation, we need to make sure that the property AutoOpen behavioral diagram is set. This property will automatically open the animated diagrams on its execution. When we launch the application, the terminal window appears. Simply click on Rhapsody so that the terminal window moves to the background for the moment. You will also notice the animation toolbar. The application is launched but not yet started. It's paused, waiting for commands from the animation toolbar. With the animation toolbar, you can now step through or go through the animated application and set breakpoints. Currently, we do not have any block instance. With Go Idle, the initial block instance gets created and the default transition is proceeded in the state chart. Then the execution is paused again, expecting further commands like go or go step. You can also observe the current count value in the features dialog of the block instance. Now we can simply press the button to generate the event Start Counting. The event is put into the event queue, but not yet consumed because the execution is still paused. With Go action, the event gets consumed and we can step further through the application. When entering the counting state, the Do Counting activity gets activated. We start with getCount to read the block instance property and the value is transferred as a token through the pin. To see the values of the passed tokens, simply right-click on a token and select Show Tokens Value. Increment and setCount, no surprise, will increment new count and write the value back to the block property. Here again the hint, this is just for demonstration purpose. Just to have a couple of actions, we could have done this much simpler. Then we pass the new count value to the print value operation, which allows us to observe the output on the terminal window. This gets especially interesting if you intend to execute your model without Rhapsody. With Go, we switch from step-by-step simulation, debugging, into a continuous execution. The Do action gets repeated until we receive the failure or the stop counting event. Guess what? Now you know nearly everything on co-simulation of SysML event and activity-based behavior in Rhapsody. Please give a like and don't forget to subscribe. That's it. Hope to see you soon. Thank you and goodbye.